Hello, welcome to Lesson 1 Introduction of CE 3372 Water Systems Design. This first lesson introduces you to the course, conducts a syllabus review, presents a tour of the resources available on the class web server, and then finishes with a brief history of water systems. I'm Theodore G. Cleveland, PhD, PE, M.ASCE, F.EWRI. That's a bunch of letters after my name. I think I got vowels so I could spell words. I'm going to miss the first 3 days of class, so sorry that you're actually listening to this on video instead of live, but we'll catch up when I get back. In the meantime, the grader will guide you to the online resources and get you all started for the first 3 class meetings. It's important that by the time you return, you have the ability to log on and upload homework to the class web server. The syllabus is posted on the class website. The fastest way there is http://theodore-macbookpro.ttu.edu/Moodle, or if you just go to the main site and take the teaching link and then choose the learning management system link, you'll get there. Moodle's a learning management system. It's like Blackboard. It's just a different software. And you're going to need a user ID and password to access the class. They'll be supplied by the grader. Once you get the user ID and password, log on to the learning management system. Be sure you can successfully log on, and then if you want to, you can change your passwords. I don't even know if you can, but don't try to change the user ID, because if you do, I'm not going to be able to deal with any things that happen over the semester, like you forget your password. Otherwise, I can just do a manual reset back to what your initial assigned password is. By way of introduction, this department, as well as the College of Engineering here at Texas Tech, is accredited by the Engineering Accreditation Commission, which is part of ABET. ABET is Accreditation Board for Engineering and Technology. It's a nonprofit, non-governmental accrediting agency for programs in applied and natural sciences, computing, engineering, and engineering technology. It's recognized as an accreditor by the Council for Higher Education Accreditation. To date, 3,700 programs in the United States have received ABET accreditation, and in 30 countries, and probably 85,000 students a year graduate from an ABET accredited program, and millions of graduates have received degrees since 1932. The purpose of accreditation is to ensure to society that we're producing minimal educational content, and our graduates are minimally qualified to engage in the business of engineering. That doesn't mean that if you're not accredited, you wouldn't be a good engineer. Accreditation has nothing to do with the quality of the person. What it does mean is that a graduate of the program should be able to be a functional engineer as far as ABET is concerned. Accreditation is very important because if your program loses accreditation, your degree, which you spend a lot of time and money to obtain, loses value. And there's very few programs that have lost accreditation, had it stayed lost, and have recovered. I'm aware of a couple in my career where they've lost and regained it, and everybody's often and happy. The usual loss is almost paperwork stuff. Here's why we have it. It ensures that graduates have met educational requirements necessary to enter the profession and provides opportunities for the industry to guide the educational process to reflect current and future needs. That's less of a truism, but we'll go ahead and give them that. And it enhances the mobility of professionals. I don't see how it does that, but so be it. What it means to you as a student. It means that your education is a trusted standard for engineering employers. What it means to the program and institution, it demonstrates our commitment to delivering quality education. And what it means to your future employers is that your ABET accredited graduates at least have preparation into the workforce. Think of it as a boot camp for engineering. One of the things we have to do is assess student performance. And to do so, we have to regularly use documented processes for assessing and evaluating the extent to which student outcomes are being attained. So The reason you do homework and it's collected and scored is part of this documented assessment process. The results of the evaluations are systematically used as input for continuous improvement of the program, and the outcomes evidence is used based on employer comments, your exit surveys you'll take when you're seniors, industry assessment, and course performance. Student outcomes are items that can be learned by the end of a class, and they're selected on a per course basis. And here's a list, A through K. I think the certain components of this list are changing over the next few years, but most of them are going to be there. Ability to apply knowledge, mathematics, design and construct experiments, analyze, interpret data, design a system, component, and process, function on teams, identify, formulate, and solve problems, understand your professional ethic responsibility, communicate effectively, understand the impact in a global economic, environmental, societal context, recognizing the need for lifelong learning, knowledge of contemporary issues, and ability to use techniques and skills of modern tools. What we expect of you are that you'll meet your program educational objectives. For civil engineers, that is, you'll meet the expectation of employers, and your graduates will continue professional development. The second one's a given because if you obtain an engineering license in Texas, you're forced to continue your professional development. Meeting the expectations of employers. If you don't do well, you're going to be working at Bennigan's. And if that's what you want to do, that's cool. But if you got an engineering degree, you're probably overeducated for the food service industry. Well, actually, wrong educated, not over. For construction engineering, the items are listed, and for environmental engineering are also listed here. For further information, you can visit the URL shown here. And now we're going to do a website tour. This particular URL is no longer correct. Instead, the URL that you want to use is theodore-macbookpro.ttu.edu. But a general layout of the content of the course, there's lectures, there's some tools, which we'll get to in a minute. There's various links to computer programs. There's the exercises, and where possible, there'll be some exams for the past study. Let's look at types of water systems. Now this comes out of the readings that you're supposed to do for this lesson. The three main types are water systems that control water, water systems that provide for the use of water, and then a third type called environmental restoration, for lack of a better name. Water control systems, they control the spatial and temporal distribution of surface runoff from rainfall events. You can think of them as water control is drainage engineering. Flood control structures, stormwater harvesting, things like that are all water control systems. The capacity of the system, how big it is based on the area that it has to serve. These are very hydrologically dominated designs. In contrast, a water use system is to provide for spatial and temporal distribution and support of habitation. So water supply, treatment, distribution, wastewater collection, treatment, and discharge. These are all use systems. It's for the use of water. The capacity, or how big these systems are built, is based on the population served. These are very hydraulically dominated designs. So we estimate population, we multiply how many people times the per water unit per person. That gives us a total amount of water units we have to deal with, and then hydraulics is applied to complete the design. Environmental restoration systems are systems that are managing spatial and temporal distribution and support a non-human habitat. Making a duck habitat and other wildlife habitat is an example of an environmental restoration system. So large areas of lands on the coast that we allow to flood at particular times of the year so that it will attract waterfowl is an example of an environmental restoration system. Their goal is to create desirable conditions, and desirable is outside the scope of engineering specifically. Desirable requires that policy be set, and policy is based on a value judgment. However, once that policy is established, then creating conditions that are desirable as per policy is very much an engineering activity. So the next video is going to discuss a brief history of water systems.